right, the first thing we're going to talk about is scalar multiplication. Scalar multiplication is really done because it's used when we get into like dilations in the next section tomorrow or on Wednesday. It's a scale factor. And so a scalar multiplication reminds me very much of distribution. All right. And so it says, suppose C is a scalar or a real number and A is a matrix. You find the scalar product, CA, by multiplying each element of A by C. And they give you this crazy big example with all of these decimals because that's the easiest way to explain it, right? So 1.5 times all of these other decimals here, right? It's basically like distribution. You're going to say 1.5 times the 0.35, 1.5 times this, so on and so forth. You multiply each product, each number within it by the scalar number on the outside, the scale factor on the outside. And then they rounded them and they got that answer there. But it's very much like distribution. You just distribute the scale factor through every single element in the matrix. So go ahead and do check understanding number 1. All right, so for this one, they wanted you to multiply 3 through to all of the numbers in the matrix. You should have gotten negative 45, 36, negative 30, 0, negative 60, 30, negative 21, 0. So then because we know scalar multiplication, you can do a combination of things. I will say that you're going to use order of operations just like you would any other time here. So if they had a parentheses, they literally could do order of operations, the whole concept there with this. So when you have 5a minus 3b, you're going to multiply the 5 times the a first. You're going to multiply the 3 times the b, and then you're going to subtract those two answers. And it works just like anything else in order of operations. So do your multiplication first, then do your subtraction. Pay attention to your positives and negatives as you do this. When you distribute this guy, you're just distributing a 5. So we have 10, 15, negative 35, 5, 20, and 25. Keep in mind that when you do this, if you leave the subtraction there, you're just distributing a 3. If you change it to adding the opposite, you're distributing a negative 3. So they just distribute a 3. Whereas normally in distribution, when you get rid of the parentheses, you distribute the negative with it. Don't do that here, else you'll still have a minus and you'll have a negative already in there. So if you distribute the negative, you must change it to a plus. All right. But otherwise, they just distributed the 3 here. So 9, 0, 18, negative 3, 24, and 6. And then you're going to do subtraction here. Again, it is adding the opposite. So when you have these negatives on this side here, pay attention to them. But we have 10 minus 9, 15 minus 0, negative 35 minus 18, by the way, negative 35 minus 18, 5 minus a negative 3, 20 minus 24, and 25 minus 6. And so your answer would be 115, negative 53, 8, negative 4, and 19. Easy? All right, so try A and B there. If A, B, and O are M by N matrices and C and D are scalars, then CA is an M by N matrix. So multiplying it by a scalar does not change its dimensions, is what it's telling you. Associative property is true of scalar. You're just multiplying through. Distributive property, that's basically what the scalar is. Multiplicative identity, if you multiply a matrix by 1, you're going to get the same matrix. And then multiplicative property of 0, if you multiply the matrix by 0, you're going to get the 0 matrix. They're all going to be zeros. Having said that, then you can start doing equations with matrices. Or we did them just like from Bell work, where you just had addition and subtraction. You can throw in scalars here. So with something like this, you would want to distribute or multiply this by the scalar first, then subtract, and then dividing. So dividing by 4 is the same thing as multiplying by 1/4, which is like multiplying by a scalar. So you can now solve something like this. You would just distribute. Remember, if it's a capital letter, then you are looking for a matrix. then you're going to do exactly like you would for solving an equation. You would subtract this guy from both sides. Remember, you're subtracting, so again, pay attention to your positives and negatives. So 10 minus 6, 0 minus 8, 4 minus a negative 4, and 2 minus 2. And they were nice, so they gave us all things divisible by 4. But you're basically multiplying by 1/4 if you divide by 4. And so that's the same thing as multiplying by a scalar on the other side. You're just dividing by 4. So we have x is going to equal 1, -2, 2, and 0. So matrix multiplication, you multiply the elements rows by columns, and we're going to do this, but there's some stipulations that have to occur. In order for this to work, you're going to figure out the dimensions. So for the first one, you have a 3 by 2, right? Row by column. So you have a 3 by 2 matrix here. And for the second one, you have a 2 by 4, right? Row by column. In order to perform matrix multiplication, these two numbers have to agree, all right? They have to be the same. And that represents, okay, I can do it. And then your answer will always be these two numbers, all right? Your answer will always be those two numbers. So the two inner have to agree, and the two outer will be your new dimensions for your answer, okay? And so as you go through this matrix multiplication, the first thing you have to check is, can I do this multiplication? Do my columns of my first match my rows of my second? All right? So order matters when you do matrix multiplication. Order matters. You'll get a different answer, or you won't be able to do it all one way, okay? The second thing is, my answer will be a 3 by 4. It's a really good check, because very often people will do row by column and then they'll start going down instead of across, and their answer will be flipped. And so your answer for this one would be a 3 by 4. All right, so just looking at the dimensions tells you, 1, can I do it? 2, what should my answer look like? All right? And so these are the rules for matrix multiplication. The other thing you have to remember is order matters. If they say multiply A times B, it is not the same as multiplying B times A. You will get a different answer. All right? So let's look at the first example here, example 4. Find the product. So they've given us these two matrices. This is a 2 by 2 and a 2 by 2. So it's very simple. Yes, you can do it, and your answer is going to be a 2 by 2. And so to do matrix multiplication, you're going to take the first matrix, and you're going to look at the rows of that matrix. And you are going to use the columns of the second matrix. All right, so we're multiplying these two. We're going to take this row, and we're going to multiply it by this column. What that means is we're going to go element by element here. I'm going to make it a little bit bigger so we can see it. Element by element. So we're going to take -1 times -3, and then 0 times 5. And we're going to add those up, and that will be my first element of my new one. So my new matrix, or my answer matrix here, I'm going to say -1 times -3 plus 0 times 5. And that will be my first element. And then I'm going to do exactly the same thing using the same row and the second column. Same row and second column. And I'm going to say negative 1 times 3 plus 0 times 0. Now, once I've done this, once I've exhausted my columns of my second one, I'm done with that row. Okay? So I'm completely done with that row. I will not need it again. I'm going to move on to the next row, and I'm going to say, oh, not with that one. We'll go this way, that way you can see it. 3 times negative 3 and negative 4 times negative 3, 5. All right? And so now I'm going to say 3 times negative 3 plus negative 4 times 5. And then I'm going to move on to my second column here with that same row. And I'm going to say 3 times 3 plus negative 4 times 0. All right? What you'll notice is that it's going to be negative 1, 0, 0. And then if you look down, these should line up. Negative 3, the 5s, the 3s, and the 0s. All right? And so once you've done that, you're just going to perform your multiplication and addition. Just in order of operations as you would. So my answer here is going to be, well, what is negative 1 times negative 3? That's 3. Plus 0 and 5, 0. So my answer here is going to be 3, right? And then I have negative 1 and 3. That's negative 3 plus 0. So this is going to be negative 3. This is negative 9 plus negative 20. So that's negative 29. And this is 9 plus 0. So this is 9. This is my answer. It's a 2 by 2, which is what I expected as my answer. All right, a used record store sells tapes, LP records, which I don't even know what that is, but and compact discs. The matrices shows today's information. Find the store's gross income for the day. Tapes, LPs, and CDs are $8, $6, and $13. They sold $9, $30, and $20. You literally just multiply. So you're going to multiply your row by your column. That's really all there is. 8 times 9 plus 6 times 30 plus 13 times 20. Not really sure why we would set up a matrix for this particular guy here. But they did. There we go. So determine whether or not it exists. Before you even start, you can decide, can I do this problem? It's a good time to decide it because it's a really pain to go through the problem and you can't do it, right? Or to come up with an answer and you shouldn't have been able to. That's even worse. All right, so when you do these, you want to write out the dimensions. So remember, it is row by column. So how many rows do I have of this first one? How many rows for G? 3. So this is a 3 by 2. And then H is a 2 by 2. So does this exist? Well, yes, because these match. All right. What is my answer going to be? Yeah, my answer is going to be a 3 by 2.
I thought it was the 2 second ones had to match.
No, the inner ones have to match. The outer ones will be your answer.
Oh, okay.
Matrix multiplication properties. If A, B, and C are n by n matrices, then AB is an n by n matrix. Closure meaning if you have the same two dimensions, then your answer will be those dimensions. Associative property. You can group them, however. You can distribute with the matrices themselves. And you have the multiplicative property of 0. You notice that your property does not mean that you can go in any order. So there's no property that set, and well, the property that applies here is that you cannot go in any order. So associative property is fine, but you do have to go in the order they give it to you, because if you multiply in a different order, you can get a different answer. All right. Questions on those?